So today what we're doing is solving a system of equations. So we want to see where two of these types of graphs intersect. Okay, so if we have, say, an ellipse and a hyperbola, we want to see where those two graphs would intersect each other. Okay, to do that, we have to solve a system of equations. So when a system of equations consists of a linear and a nonlinear equation, the system may have zero, we're quiet now. The system may have 0, 1, or 2 solutions. Okay, so some of your possible solutions are shown below. So say we have 0 solutions or no solutions. Your line doesn't intersect your other graph at all. Okay, that's what that means. If you have 1 solution, your line will intersect that other graph at only 1 point. Or you could have 2 solutions, such as this hyperbola and this line. Okay, the line intersects at both of those points there. So that would give you 2 solutions to that problem. So we can solve linear quadratic systems. You guys are talking way too much. You can solve linear quadratic systems by using graphical or algebraic methods. So I'm going to show you how to do this algebraically, and then I'm going to show you the graph. So we're given 2 equations here. Okay, so one of these is a linear equation. That's this top one. There's no exponents in either variable, right? They're just standing alone. The second one, okay, we do have exponents, so that one's not linear, it's not a straight line. So my first step here, is to solve the linear equation. For y. Okay, so that's this one right here. Again, because there's no exponents. So in order to solve for y, we want this to say y equals something. So I'm going to distribute this 3 to both of these terms and this 2 to both of these terms. Okay, so I'll have 3y minus 12, right, if I distribute that 3. Next, I'm going to distribute this negative 2 to both terms. So I have minus 2x plus 6 equals negative 6. Okay, again, all I was doing was distributing that to both terms there in both cases. All right, so here what I want to do is combine like terms. So I have 3y minus 2x minus 6 equals negative 6. So I just combine that negative 12 and that positive 6. Okay, now again I'm trying to get y by itself. So I'm going to add 6. So I have 3y minus 2x equals 0. Add 2x. And then divide by 3. So I do end up with y equals 2/3 x. Okay, I wanted to solve for y because now to solve this system, what I want to do is plug in what I found for y. So you're substituting. Okay, so step 2. is to substitute into the quadratic and solve for x. Okay, and I'm substituting what I found for y. So I'm going to plug this in to that y value there. Okay, that's what I'm doing when I'm substituting. So now I'll take 5x squared, add 2. Now instead of it being y, I'm substituting what I found y to be in for that value. So I have 2/3 x, and that quantity is squared. Minus 53 equals 0. You have a question?
Where did the 12 go? I'm trying to explain.
I added negative 12 and 6 to get negative 6.
Okay, that makes sense. So I just did it more now. I didn't see that.
Okay, so do you understand how I plugged in that y value into that second equation there? All right, so now from here, what I want to do is solve for x. So first, I'm going to square this term. So I have 5x squared plus 2 times the quantity. You need to square both of those numbers in your fraction. Okay, so I have 4 over 9x squared minus 53. Okay, so all I did in that step was square what's in that parenthesis there. Okay, next I can multiply. So we have 5x squared plus 8 over 9x squared. So I just multiplied my 2 and my 4. Minus 53 equals 0. Now I do have this fraction here. So to get rid of that fraction, to make this a little bit easier, I'm going to multiply that whole equation by what's in the denominator of that fraction. So we're going to multiply everything by 9. Okay, so I'm going to take 9 times 5. That's 45x squared. Now this was the reason I'm doing this. If I take 9 times this fraction, my 2 9's here cancel. So I'm left with plus 8x squared. And then I still have to multiply 9 times this 53 here. Okay, and that's 477. And then 9 times 0 is just 0. So I just multiplied each of those terms by 9 to get rid of that fraction. So now it's a little bit easier to combine my like terms here. So I have 45 plus 8, and both of them have that x squared. So I have 53x squared minus 477 equals 0. Okay, and again, what I'm doing is solving for x, so I'm going to add that 477 to both sides. Okay, from here I can divide both sides by 53 to get x squared by itself. So I get x squared is equal to 9. It's solving a system of equations. Yeah, it happens. This one? Okay, so since this is a fraction, right, I want to get rid of the fraction. So I'm going to multiply each term by whatever is in the denominator. Okay? Make sense?
What?
When I take the square root of both sides, you have to add in that plus and minus. Okay, so it's not just 3. So x will equal plus and minus 3. Okay, because if I take negative 3 and square it, I still get 9. That's why you have that plus and minus there. Okay, I have one more step because you're solving, yeah.
I'm just gonna put solve.
What?
Instead of
Here? I added these two. Okay, you do have one more step. So since you found x, when you're solving a system, you're looking for the coordinate points where both of those graphs intersect. That means you need the y values too. Okay, so we're going to substitute the x values into the linear equation. And solve for y.
Whoa, what?
Okay, so again, we need these coordinate points. Right now, all we have are the x values, and we need the y values to make it a coordinate point. So when x is equal to 3, since I found x to be 3, we're going to plug that 3 into our linear equation that we found, and I'm just going to use this one. Okay, you can plug it back into the original, but you're going to get the same answer. So I'm going to plug it into this one right here. So we have y equals 2/3 times our x value, which is 3. Okay, those 3's are going to cancel out, and we'll end up with y is equal to 2. Okay, I do have one other x solution. So we need to plug in, negative 3 as well. So we'll have y is equal to 2/3 times negative 3. And again, those 3's cancel, but you'll end up with negative 2 instead. Okay, so my answer for this problem, I would end up with when x is 3, y is 2. That's one coordinate point where these graphs intersect. And when x is negative 3, y is negative 2. That's another coordinate point where those two graphs will intersect. Yeah. Do you not remember last year when you had to solve a system of 3 equations?
No, yeah.
Most definitely did that last year.
I did.
Showed us something that was like a cheat.
Right.
We never had to write stuff out that big.
Yeah, we did.
A system of 3 equations takes over an entire page. Yes, it does.
I didn't do it. I filled out
All right, so this is algebraically. I'm going to show you the graph of this. Relax, you're not graphing it. I'm going to show you the graph. So here's your linear. Okay, that was that first one. The second one was an ellipse. So that's this one right here. You can see that it intersects at 2 points, and we found 2 points. Okay, one point was at 3, 2. That was this one right here. Okay, another point was at negative 3, negative 2, and we found that out as well. Okay, so that's what we were looking for. We're looking for those intersection points. So yes, you can graph it to make sure you did it correctly, but you need to actually solve the system first. Does that make sense? All right, so that was with a linear and another equation. If you go to the back, we have more than just a linear equation with another. Okay, if a quadratic system contains two conic sections, which is what we've been working with, the system may have anywhere from 0 to 4 solutions. So here we have some representations. So this first one is a parabola and a hyperbola. Okay, those two don't intersect at all, so they have no solutions. Guys, let's put the phones away and pay attention. Come on. Here I have one solution, so my one graph hits my other in exactly 1 point. This one here I have two solutions. Here would be 3. And then the last one, yes, you can have 4 solutions where that graph intersects at 4 different points. So we're going to go through another example here. This one is not linear, so we don't want to solve for x or y and plug it in. What we're going to do is use the elimination method to solve this. Okay? So if I'm looking at my two equations here, I want to eliminate one of my variables to solve for the other. So I notice that I have a 4y squared and a negative y squared. So I'm going to multiply this whole bottom equation by 4. Okay, so I'm going to multiply that whole bottom equation by 4. So I'll have 3x squared plus 4y squared equals 48. So that's that top one. I just rewrote it. For the bottom one, I'm multiplying each term by 4. Okay, so I'll have 8x squared minus 4y squared equals negative 4. Okay, the reason I did that was so I could add these two equations together. Because when I add them, these y's right here are going to cancel out. They're going to eliminate, hence elimination method. Okay, because I have 4y squared minus 4y squared. So I'm going to add these two, so I have 8x squared and 3x squared. Get 11x squared. Again, these ones cancel out. They're 0. So then I just have my equal sign left. And I'm adding these two to get 44. From here, I still want to solve for x, right? So I'm going to divide both sides by 11. So I have x squared equals 4. Take the square root of both sides. X is equal to plus or minus 2. And again, don't forget that it is plus or minus. Okay, just like on the front, once I find x, I need to find y. So I'm going to plug in when x is equal to 2, and it doesn't matter which equation you plug that in for. Okay? You're plugging in 2 for whichever x value in your original. Shh. Please stop talking. So I'm plugging in 2 for x. I'm going to use this bottom equation. So I have 2 times 2 squared minus y squared equals negative 1. Okay, from here, I need to solve for y. So I have 2 times 4 minus y squared equals negative 1. So we have 8 minus y squared equals negative 1. Subtract 8. divide both sides by -1, so we'll end up with y squared equals 9. Take the square root of both sides. You'll end up with y is equal to plus or minus 3. So whenever you take the square root of both sides like that, it is plus or minus. Okay, what was my other solution for x? -2. So I have to plug in -2 as well. Okay, I'm going to do the same thing. Plug in -2 here. So we have 2 times -2 squared minus y squared equals -1. If I square -2, I end up with a positive 4. Now, don't these two look the exact same? Right? So that means when I finish this, I should end up with y is equal to plus or minus 3. Okay? It's the exact same equation. So I'd have 8 minus y squared equals -1, negative y squared equals -9, and y squared equals 9, and take the square root of both sides. All right, so once you get to this point, you don't just stop, you have to write them as coordinate points. Okay, so when I plugged in 2 for x, right, I plugged in 2 for x, I got 3. I also got -3. So when I plugged in 2, I got 3 and -3, so those are 2 different points. Okay, and then over on this side, when I plugged in -2 for x, again I got 2 different points. I got a +3 and a -3. So this one has 4 solutions. Okay, questions on example 2? Okay, then I'm going to get started on example 3. So again, we're solving a system. So again, I want to eliminate one of my variables. So I'm going to eliminate my x squareds this time. Okay, because both of them are already x squared, right? So I just need to multiply one of these by -1, and I'm just going to choose the top one. Okay, so as I multiply through, I'm going to rewrite it over here. So I have -x squared minus y squared, and then equals -8. So I just multiplied each of those terms by -1. I'm going to just rewrite my second equation below that. So I have x squared plus 3y equals 10. And again, we're just adding the 2 equations together. Here, my x squareds cancel. So I have -y squared plus 3y is equal to 2. Okay, because I can't combine these two, they're not like terms. So I just added them there. When I see something like this where I have a y squared and a y, that means I'm going to have to factor it. Okay, so I need everything on one side of my equation, and it needs to be equal to 0. So I'm going to add y squared to both sides here and subtract y, 3y. Okay, that way I end up with 0 on one side. Then we have y squared minus 3y plus 2. Are you still with me on this one? Yeah. That way I have a positive y squared. You could, and then I just divide it all by -1, so I wouldn't have that negative y squared. in order to factor it. It makes it a little bit easier. So from here, I want to factor this. So you can use your x method. So multiplies to get 2, adds to get negative 3. So what two numbers multiply to get 2? 2 and 1. And they're both going to be negative, so they can add to be negative 3. So I'll end up with y minus 1 times y minus 2 equals 0. Okay, now both of those quantities have to equal 0. So we'll set y minus 1 equal to 0 and y minus 2 equal to 0. So y will equal 1 and y will equal 2. Okay, again, from here, what's my next step? What do I have to find yet? X. So we're going to substitute. To find x. So when y is equal to 1, I'm going to pick an equation to plug that into. I'll just use this top one. So we have x squared plus 1 squared equals 8. So I'm just substituting my value I found for y. So we'll have x squared plus 1 equals 8. Subtract 1 from both sides. Get x squared is equal to 7. We want to take the square root of both sides. Now I'm just going to leave it in that root form. You don't need to plug it into your calculator and get a decimal. We can just say x is equal to plus or minus the square root of 7. Okay, we have one more term for y here. So when y is equal to 2, and again we're substituting 2 in for y into that equation. So we have x squared plus 2 squared equals 8. So we have x squared plus 4 is equal to 8. Where x squared is equal to 4. Take the square root of both sides. And x will be equal to plus or minus 2. Now with this one, you need to be careful of how you set up your coordinate points. This is your y value, not your x value this time. These are your x values, so they need to be first in your coordinate point. Okay, so my answer here, I'm going to start with positive square root of 7. When I have positive square root of 7, my y value is 1. Okay, and then I can say negative square root of 7. My y value is also 1. Same thing over here. When my x value is positive 2, my y value is 2. And when my x value is equal to negative 2, my y value is 2. Again, this one has those 4 solutions then. Okay, just make sure you know what the x and y mean. It's your coordinate point on a graph. X's come first, y's come second. Any questions on this last one?